All right, good morning, everyone. My name is Paul Grizzaffi. I'm going to be talking about bad tests running wild. We'll get to what that means here in just a minute. But again, Paul Grizzaffi, I am a senior principal automation architect at Nerdery. I've been there for almost a year. Career's been focused on automation, and I'm an advisor to the Advanced Research Center for Software Testing and QA here at UT Dallas. And if you want to talk to me about testing or about Slayer, I'm equally happy to talk to either of y'all, or talk to y'all about either of those. If you want to contact me outside of this forum, here's my contact info. I'm in most of the places, and then that last URL down at the bottom is where I blog some hopefully cogent blogs. So, 1984. Anybody alive in 1984 like me? Yeah. 1984, Scorpions released their record, Love At First Sting. The first big hit on this multi-platinum record was Rock You Like a Hurricane. Most of you have probably heard that song, if not on the radio, on a sporting event or commercial or something. But what's always appealed to me when I hear about bad things is the opening song, which is called Bad Boys Running Wild. So I named this talk Bad Tests Running Wild because a lot of times when we decide we're going to press that little button or we're going to check that little box that says run our test automation in parallel, things go wrong. Things go haywire. And why is that? Why is it that we can't just press the button and go? Well, intermittent failures, right? Whose test automation runs 100% every time, passes every time? Whose runs consistently every time, right? We all have these little nagging problems that sort of stick around and bite us on the bottom along the way, right? Because we got the passes and we got the fails and we run it again and we got different passes and fails this time, right? Yep, intermittent problems. Why do we have intermittent problems? Well, we have problems. The software is inconsistent, right? Let's blame the tests right away, right? Flaky test automation, absolutely. We write bad automation sometimes. Flaky infrastructure. How many have ever said that only happens in QA? Right? I heard it yesterday, actually. But hey, sometimes there's actually a flakiness in the application. Either intentional or unintentional, there is a flakiness in the app. So what do we do? How do we get the speed we're looking for? How do we get the parallelization we're looking for test automation if we're going to have these flaky problems? Or are we just going to cut off our toes? So I'm going to talk about 3 different aspects of shoring up your automation so that it has a higher chance of working appropriately when you parallelize it. So first, we have the development part. Threads and concurrent processes. Most of us know what these are if we do any sort of software development. Threads are lightweight ways to run multiple things at the same time on the same computer in the same program. They're very powerful, but potentially problematic because your code must be what's called thread safe. We'll get to that here in a minute. And if you depend on third-party libraries, which we pretty much all do these days, they must be thread safe as well, otherwise your program will not be thread safe. Similar but different to threads, we have concurrent processes. Those processes, they're much more heavyweight. They run concurrently as well. It gets rid of some of the problems you might have with threading and safety, but still external data sources and external resources will still be something that you have to contend with from a contention standpoint. So what is thread safety? It's a safe manipulation of data constructs inside of a program. There are ways to make your code thread safe. Reentrancy, meaning that you can go back into the code that you're currently running with another control flow. Pretty hard to do, but it is doable. Mutual exclusion, so a semaphore, a one count semaphore. Only one flow can go through this particular code at a time. That way it gets thread safe, right? You don't have to worry about anything getting messed up or contention for writing to a file or writing to a memory location. Atomic and non-interruptible methods, and immutable or unchanging objects, right? If the object doesn't change, then you can always read from it. You're not going to write to it, so everybody can look at it at the same time. and look for your thread-safe data structures and libraries if you're looking for these types of things. There's a lot to talk about with thread safety. I'm not a super expert on it. So in the interest of time, we're going to move on. But these are some things you need to look into if you're going to start running your test automation in parallel. But we have to be aware of something called deadlock. And we'll get to that here in a couple of minutes. But before deadlock, let's talk about race conditions. Who's heard of a race condition here? Okay, so a race condition is something that can happen in your program when events can fire or happen in any given order. A can come before B, or B can come before A. Non-deterministic. Handled race conditions are fine. I'm going to click this button before this button, I'm going to click this button before this button. I'm going to fill in my last name before my first name, and my first name before my last name. Our event-driven programming, especially when it comes to GUIs and interacting with third-party systems, all based on this sort of event-driven programming and these handled race conditions. The unhandled race conditions are the problem. If you always expect A to come before B, but B comes before A once in a while, you're going to get a different behavior. And if your test automation is expecting it in the A comes first and not the B, then it's going to be flaky, or it's going to appear to be flaky. Or perhaps your system should have A always before B, and it's a bug in your system. I promise we're getting to deadlock. Deadlock. Okay, deadlock is what happens when no entities can continue processing because each is waiting on something the other one has. So suppose we have two entities, tasks, programs, whatever, things that are running on our computers, and they both need two resources to perform some activity. So we have entity 1, entity 2, and we have resource 1 and resource A and resource B. If entity 1 grabs A, but before it can grab B, entity 2 grabs B, now we're in deadlock. They're each waiting on the other because they can't get it. And there are ways to detect and to avoid and to manage deadlock or possible deadlock situations, again, outside of the scope of what we can talk about here. But these are one of the things that we have to consider when we start talking about running our test automation in parallel. Now, I talked a lot about development stuff here, right? Are we developing an app or are we writing test automation? Yes, the answer is yes, we are. Both of those things, because test automation is software. Even if you're doing record and playback or AI or whatever, there are some aspects of it under the hood, behind the curtain somewhere, that there's programs running there. And we have to treat it that way. And if we don't, we're going to run into problems, including deadlocks and flakiness. And some of the development that we do, depending on how low we're going, sort of in a programmatic stack, it may have to be thread safe as well so that we can do parallelization. Okay, so for those of you that knew all of that, or that don't do the programming part in your DevOps world, there's a configuration part. We all kind of know about configurations and stuff. And configuration can be something that will limit us or cause us problems from a parallelization standpoint. So do we have enough credentials? I worked on a project one time where you could log in multiple times with the same set of credentials into the app. But if you stopped using the first login that you had, after a while it would time out, and it would log all the other instances out with a terrible error message. We couldn't figure out what was going on. So a lot of times you need separate credentials just to log in because you can't do things in parallel with the same user ID. And sometimes you can step on, right? You can step on yourself. I'm logged in as me here, and I make a change here. What's going to be reflected over here as well? And that may change the state of whatever I'm trying to do. So does your app require logging in? Most apps these days require logging in to do anything interesting, especially if you're in the finance world or the medical world, any of that stuff, even e-commerce, right? You can go to whatever, browse, put something in the cart, but at some point you're going to have to log in. So we will need credentials for that. Can the same user log in more than once? Is that something you want to test? Is it something that's supported, something that's blocked? The more parallelization you want, you may need a whole bunch of credentials. If you want to run 100 test cases in parallel, you might need 100 credentials. And if we can log in more than once, like I said, can we mess up the data state or the program state by interacting simultaneously? And how hard is it to obtain new credentials? I've worked in companies where they do not allow, quote, service accounts. Everything has to be tied back to a human. It makes doing test automation in parallel very, very difficult because we can't get the credentials that we need. We can't go the way we want to go because the system and the process limits us. And then there's the data. I already talked about messing up the program state, but do you have enough data? Do you have the right data? Because in general, managing test data is a pain. It just is, right? And I like Trace's talk before about we're generating test data, using AI to generate test data. I think that's a great use of AI. Because each concurrent test script might need its own data. Because again, especially if we're doing transient data like airline reservations and airline tickets, once you move from one place to another in the system, you went from ticketed to boarded, right? You can't go back. You can't go back. And you have to reset that data. But then if you're trying to run multiple test cases against that same data and the state changes, you start getting flakiness. Then you start to not trust your automation. Then you stop running the automation and you've wasted a bunch of money. And inattention to test data can absolutely cause the inconsistent behavior. And then there are the execution environments. Well, if you want to go fast, you have to have more, right? You have to have more processors and more memory and more disk space and all the things to do this all in parallel because a lot of stuff just can't run on one single machine. You need enough horsepower. Because on a single machine, concurrent automation typically runs slower. You run more, it runs slower. Just basic computer stuff there, right? For any appreciable concurrency, especially if you're working with some sort of a GUI, more than one machine is going to be needed. And cloud-based grids, so Sauce Labs, Browser Stack, Lambda Test, all those are good candidates to manage your grids for your browser testing. And they also, I think they all three of them, also do mobile device farms as well. So you have to manage all those things. It costs, of course, but it's a trade-off. Do you want to manage all that yourself, or do you want to pay somebody else to manage all that for you? And then the tool support. I don't think this is a big deal, as big a deal as it used to be, but some of the tools either didn't support parallel execution, or they would only support parallel execution across multiple machines, meaning if you only had one machine, you were not going to be able to do anything in parallel. And licensing, again with the money, right? So sometimes you need one license per parallel execution, especially if you're going across machines. It's more money. Now, fortunately, a lot of the tool vendors, if you're not going open source, they will have a runtime license and a development license. The development license is much more expensive because you can actually do the development using it, and then the runtime licenses are for just your execution machines that are actually doing the execution for you in an unattended way. And can you run it on a single machine? And is that even interesting for whatever it is that you're doing? If we're looking at API test automation, yeah, you can do a whole lot on one machine because you don't need to fire up a GUI. There's no contention with the GUI. They are generally lighter weight and faster to run anyway. So that's a great candidate for parallelization on a single machine. But we have to parallelize appropriately. How fast is fast enough? If I got my smoke test that I'm going to run on every deployment, if I got it down from 15 minutes to 10 minutes, is that fast enough? Well, that's a 30% improvement. That's pretty good. But what's your tolerance? How fast do you need to go? So don't necessarily strive for the fastest you can get. Strive for the fastest that you need. And everybody's going to have a different tolerance and a different need there. So don't over-engineer this, right? Go faster than you are today, and then check it out. How's it going? Is it consistent? Am I getting value from this? Am I putting more money into this? So start with what's appropriate, and then evolve as you say, yeah, you know, it was 10 minutes, but now we added these other tests, now it's back up to 12. Well, maybe you want to parallelize that a little more. Or the tolerance of 10 minutes is terrible. It's got to be down to 5 because of business reason ABC. All right, then tweak it, work on it. There are different ways to go about doing this stuff. But when we talk about appropriate, this is a picture of my old automation lab. And that's a third of the PCs that were in that room. It was really hot in there. But we could run in parallel on those old laptops that were about to go out to the recycler. And we needed some hardware for a data center migration that we were doing. And I said, what do you got? And they said, we got these old PCs. I said, we'll take them. And then the risk part. Everything we do revolves around risk, and that's the dirty secret about testing. It's not about finding a bug. That's a nice side effect. It's about identifying risks to the product, to the company, if we release today versus releasing tomorrow. What do we see? What did we not see? What would we like to have checked in addition to what we did? These are all risk decisions that the business people can understand and make a risk assessment on whether to release now or not now. So look, here we got this picture of this little girl by this alligator. Risky, right? Risky behavior. Now, we don't know if that's a real picture. Could be AI, could be Photoshop. She could be from Louisiana. She's just shopping for dinner. We eat them down there. Anyway, risk. We need to understand what our risk profile is and behave accordingly. So a lot of times we have this notion, this heaven, right, of every time a developer commits to the code repository, we're going to do all of the building and the testing and all the things. We're going to plummet right out into production. Boom. No human eyes. No human eyes will have seen it at that point. There's a risk. Who ultimately uses software? By and large, it's humans. So it seems like having a human in the mix along the way is probably pretty smart. But if you don't want to do that, or you think you don't need to do that, you need to do what I call going too low. You have to have a low cost of change and a low cost of failure. The cost of change, how expensive is it for you to make a change to your code and get it plumbed out again if a problem is discovered? If it is expensive, you probably need human eyes before you do it. If your cost of failure is high, like let's say life-critical software or automotive software or airplane software, right? If your cost of change failure is high, you probably want human eyes. And if both of those are low, you probably still need human eyes, because like I said, who's consuming this software? Who's using this software? We are. You know, it maybe not directly, maybe indirectly, but we're consuming the results of the software. But if you want to do this, you got to have good logging, and good logging from your product, and good logging from your test automation, so that you know what did and did not happen as best as you can tell. So when we talk about logging, think about logging as a trail of breadcrumbs that can help you reduce your cost of failure. The longer it takes you to figure out what a problem is and where it is, the more expensive it is to fix, right? Just effort at that point. So unattended execution, like we do in our pipelines, right? In our CI, CD, CT, all that stuff. Unattended, which means we don't have eyes on the screen watching it where we can just notice and go, oh, hey, that didn't look the way it was supposed to. Now, there are ways to do that. You can run videos and screenshots and all sorts of stuff, but that's just a different type of logging. So we'll need better and more appropriate logging to deal with the unattended nature of what we're trying to do. So I like to follow the 3 ABLEs. The logs must be available. Seems obvious, right? But I had a client one time that said their first test automation initiative failed because not everybody could get to the logs and the results of the tests, which, what'd I do? Oh, there we go. Thank you. So available. Everybody that needs to be able to act on these results needs to be able to view them in an appropriately easy way. And applicable. We have this idea of too much logging or not enough logging, right? If we have too much logging, it's too hard to get through. It becomes noise, and there's just too hard to get through, and it extends that time to feedback. It extends that time to figuring out the failure. But if we have too few logs, then we don't have enough info. We have to run it again. Oh, it's an intermittent problem. It didn't happen this time. So what logs did I need to add in to see what's going on here? And understandable. Wouldn't it be great if you got a log message that said, hey, the login button wasn't visible when you tried to click it, as opposed to couldn't find HTML element ABC123 on line 4, right? Which one's more readable? Which one is going to get you moving to find that issue faster, right? The first. And review. Well, review our test automation code just like our production code, right? Okay, you don't have to answer that. We need to. We need to treat it like code. We need to review it, but we also need to review the logs. What is the product, the end result of running test automation? It's logs. The logs give us information so we can make risk assessments. So we have to review the logs, and we have to review them during code review. Run the test, look at the logs. Did it do what I expected it to do? Could I understand this? Make it fail. Make it fail, and then can you determine that the failure you made happen is reflective in that log? Okay, so I'll wrap up real quick with a couple of takeaways. Thread safety. So if you're going to parallelize, go thread safe. Have to, otherwise you're just going to have a bad time. Appropriate environment. You have to have the right environment. You have to have enough of them, along with the appropriate data and enough and appropriate credentials with the right access and authorization and all. I will be around. I don't know if we have time for questions. I will be around the rest of today and probably tomorrow, so come flag me down out in the hall. We have time for questions or no? Yep, okay, questions. Everybody ready for a break? All right, cool. Hey, thank you for your time, everyone. I'll see you around. Appreciate it.